to Alltop School classroom. This is the question for 2022 Aime question number 15. Let's look at the question. Two externally tangent circle omega 1 and omega 2 have centers O1 and O2 respectively. A third circle omega passing through O1 and O2, intersecting the O1 and O2, omega 1, omega 2 at the 2 points B and A respectively, as shown. And also intersecting the other 2 points C and D. So the top 2 points have the distance 2, and the bottom 2 points have the distance 16. So these ABO1, CDO2 is a convex hexagon. We need to find this hexagon's area. This is already been highlighted. So by looking at this diagram, there's no any symmetry, anything. Even, for example, we're gonna try to cut this one into pieces. For example, I'm gonna cut this one into triangle, something like that. And on right side, we cut the triangle. I don't think we can do anything, right? Because the middle one, the quadrilateral is not a regular, it's not a symmetric. It's not a trapezoid, it's not like parallelogram, anything like that. Unfortunately, none of these cutting will make you happy. You're probably wondering, can we do the area on the top, AB, O1, O2? We know the two top side, and then the two legs, one is the radius of R1. Let's say this is gonna be called R1, the radius one, the other one gonna be R2. Based on this radius, we may use the cyclic quadrilateral to find the area, but the thing is, there's R1, R2 are unknown. The same thing on the bottom. You can do the top and the bottom sides. We have the 15 and 16. Eventually, we still need to depend on the value of the two radii. So we won't be able to find that very easily. So this is a pretty ugly shape. It's not a standard. It's not easy to cut into the standard shape to calculate the area. We have to think about the sum of the shape. The shape can be easily used to calculate the area. So this question has a little trick over here. The main thing is the omega 1, omega 2 are tangent to each other. So the connecting line segment between O1 and O2, you can put a perpendicular bisector and do the reflection for these 2 points so that the A and the B reflected on the left-hand side. So because this is a larger circle anyway. So from here, that's possibly we can just convert this hexagon into a symmetric hexagon. So we can just cut them easily into smaller triangles and also some better shape of the quadrilateral, such as quadrilateral, like trapezoid, parallelogram, or something like that. So that's the main idea. So we have several steps to solve this problem. The first step, we need to convert this hexagon into more symmetric. You can see we can reflect AB across the perpendicular bisector O1, O2. That's the two circles. They are tangent to each other. We get a A1, A prime, B prime, just like this. So by looking this is symmetrically A reflected to A prime, B reflected to B prime. We converted the hexagon into O1, A1, A prime, B prime, and then O2, DC. Just, move these 2 points to the same circle omega, but on the other side of this omega. So we get the better shape. This new hexagon will have very nice shape. In the middle one will be trapezoid. On the both sides, we'll get these two triangle. We can prove they are going to be congruent. So these are going to be reflect these A and B cross the perpendicular bisector of A01, O2. And then we're going to get these two triangle congruent. And also we get this trapezoid in the middle will be isosceles. From that, we can just calculate this area of the trapezoid. And also we just calculate one of the congruent triangle area. So you get this. Let me get rid of this mess. We get these two triangle congruent. And then once you get these two congruent triangle area, get the isosceles trapezoid area, and then we're done. So this is the first step. Step 2, we're gonna do is apply Ptolemy theorem in this trapezoid. So actually we know this top length is 2, the bottom one is 16, but we really need to figure out the diagonal B prime C and then A prime D, okay? Because what is the Ptolemy theorem? Ptolemy theorem, you're gonna get this circle and then any quadrilateral inside the circle, we call the side is A, B, C, D. And then we get a diagonal we call D1, D2. The Ptolemy theorem will be like this. The opposite sides multiply together. The sum will be exactly equal to the product of the diagonal. So that's a very nice Ptolemy theorem. We can use it. So that means over here we need a diagonal B prime C, A prime D. So that means the goal is to find the legs A prime C, B prime D. So we need to find out O1 B prime, O2 C will be, because that's using B prime C. B prime C is going to be another diagonal for the other trapezoid. Okay, if we do, so that means we're going to do this way. B prime C is the one we're looking for. But directly from this trapezoid, we cannot find anything. But if we can just utilize the other trapezoid, O1 C, O2 B prime. So you will find out that's two diagonal, O1, O2, and then this one B prime C will be the same. The only thing we need to prove will be this isosceles trapezoid. Okay. So we just need to identify this isosceles trapezoid. We get this B prime C inside the trapezoid, the blue trapezoid, A prime, B prime, DC. Okay, that's, you get it. If you can figure out this one, isosceles trapezoid, we get this one 15, the same as the other diagonal. Okay. So from Ptolemy's theorem, and then we can find out A prime C. Once we find out B prime C, A prime D in the trapezoid A prime, B prime, DC, and then we just figure out A prime C them. That's the second step. Try to identify the diagonal B prime C. This diagonal share between the two quadrilateral. One is the trapezoid where focus. The other one is the one with the same length of O1, O2 for that diagonal. So we figure out that length will be 15. Okay. So that's nice. After that, we apply the Ptolemy theorem to find out A prime C. The step 3, we're gonna get this value already, the diagonal 15. We know this is a 2. And then also from the Ptolemy, we get this one as well. So in this triangle, we can apply the law of cosine to find the cosine angle for this one. What's the reason? Because I want to find the angle in the base in order to find the height of this trapezoid. This is alpha. If I can find out cosine alpha, we can find out cosine alpha on this larger right triangle. So we already know this is 15. If I know cosine, certainly I can find out the B prime H, the height of the trapezoid. And then once you get the height of the trapezoid, we're done for the trapezoid area. Okay, yeah, this the step 3, just try to find cosine alpha in this smaller triangle. And then the step 4, we only need to calculate the 2 shaded congruent triangle area. We already know this is the R1, this is the R2, right? That's the 2 radius of the 2 smaller and 2 circles. And then what is this area for the left-hand side? Are gonna be R1, R2 times 1/2 times the sine alpha, because you can see this quadrilateral cyclic. If this alpha, this is gonna be 180 minus alpha. So the cos sine 180 alpha will be the same as sine alpha. This is R2, this is R1. So this area, we can find it 1/2 of R1, R2 sine 180 degrees minus alpha. So you get the area. So certainly this is the same as sine alpha. So the only thing we need to figure out will be R1, R2, the product of the 2 radii. But we know this R1, R2, you can hear. This is the R1, this is R2. R1 is here, R1, R2 is here. They add together equal to 15 is given. So from here, we can use perfect square formula to figure out. Let me clean this up. From here, we can apply law of cosine in this triangle. Yeah. But earlier one, we already calculated cosine alpha, certainly sine alpha we calculated. But using law of cosine, apply with this R1 plus R2 equal to 15, and then you can eventually find out the product of the R1, R2. All right, that's the whole steps. Solution step 1, we're gonna do as we plan, reflect this A, B into A prime, B prime across the perpendicular bisector for O1, O2. So we'll get this nice hexagon O1, A prime, B prime, O2, DC. And then this is very symmetric. The new hexagon has the same area as the original one. Yeah, certainly that's true. For original one, think about it. They're gonna be this, right now is the same as this. You remove that from the whole circle. And then also, for outside of this B prime O2 is the same as BO1 earlier one, because they are symmetric. So that's why the new hexagon area will be the same as the original one based on the symmetry. So look at this one. The blue line segment, green line segment will be the same. By looking on the right side, is going to be the radius of the second circle omega 2. So certainly this one will be equal based on A prime O equal to A O prime O2 because they are perpendicular bisect over here. So they are symmetric on both sides. So this one will be equal to R2 as well. Same thing for the orange. Orange on left-hand side, this one is R1, R1. And then BO1 certainly equal to B prime O2 based on the reflection. So they're going to be equal. So that's why there's going to be the, this one will be equal. I labeled incorrectly. This is supposed to be this orange. And then this orange and this orange, that will be the same. Now this one, this should be the blue one. Okay, and then we're gonna get this congruency, orange, and angle 1 equal to angle 2. What's the reason? Because they are facing the same green color inside the omega. Angle 3 equal to angle 4 because they are facing the same orange color. So angle 3 facing this R1. This angle 4 facing R1 as well. So angle 3 equal to angle 4. So that's why the two triangle will be congruent. Okay, two congruent triangle is being determined. And then meantime, this middle one trapezoid will be isosceles trapezoid. Okay, A prime C equal to B prime D. This is going to be isosceles trapezoid. At the same time, also certainly the diagonal will be equal. A prime D and B prime C will be equal. For the two diagonals, we're going to use in the Ptolemy theorem. Okay, that's first step. We're done. Step 2, we're going to do, you see, O2 B prime equal to O1C. Okay, this one equal to this. Both will be equal to R1. Okay, and then we will get what? The two arc will be the same. See, on the omega, this arc and this arc will be the same. Once you get this arc the same, the two line segment will be parallel. Okay, any circle you can think about it, you get these two equal. So you're gonna get these two parallel. Okay. All right. Once you do it, certainly that's easy to prove. And then in that case, we can see the diagonal B prime C is equal to O1, O2 equal to 15, because our purpose is try to get this diagonal of this trapezoid in order to use the Ptolemy theorem. Eventually, we try to find the length of the leg, A prime C. Okay, and then they're going to be isosceles trapezoid. The diagonal will be both equal to 15. So A prime D also equal to 15 because this is isosceles trapezoid earlier. Okay, we figure out the requirement for the Ptolemy theorem in a blue trapezoid. Now we can apply the Ptolemy theorem. Okay. The Ptolemy theorem will be using this one. Okay. A prime C times B prime D plus 2 over, you see, this is a 2. This is times 16. And then equal to the two diagonal multiplied together. The two diagonal both equal to 15. So we figure out from here, A prime C multiplied by B prime D equal to 225 minus 32. That will be 193. So we figure out the leg of this trapezoid, A prime C and B prime D, square root of 193. Okay, that's a completely solved for this trapezoid. Okay, the leg we figure out square root of 193. Okay, and then diagonal 15, the leg is square root of 193. And then suddenly from here, we can directly do the calculation. We can directly calculate the height of this trapezoid because this trapezoid has all the sides and legs are calculated. We certainly can do the, for example, the height, we can use the Pythagorean theorem to do it. Very easily to figure out. But in order, because later we need to utilize the angle alpha anyway. So we're gonna use the angle alpha to find the height, which make things more useful. So to find this area, I believe everyone can do it. You can, for example, I'm gonna draw the height. This length will be 16 minus 2 divided by 2. That will be 14 divided by 2 is 7, right? And then this is the height, you can calculate it. Okay, the height will be equal to 193 minus 49, 144. That's exactly 12. We find the height. So the area of the trapezoid can be solved. But the thing is, we still need to figure out this triangle area. So I need these angles sine alpha, this angle theta. So that's why we need to figure out this angle using this part of this trapezoid, find this cosine alpha. And because this one we don't know for the R1, R2. So we still need to calculate this cosine alpha in order for us to calculate this cosine. All right, so let's do step 3. This alpha inside this part of this trapezoid, we'll recalculate this sides 193. And this is a 15, this is 2. We can easily calculate this cosine alpha. That will be 3/5. Sine alpha, because eventually we want to find this triangle area, we need a sine alpha. So that's equal to 4/5. And then we're going to draw a perpendicular line B prime H perpendicular to the base of this trapezoid. We can figure out, just like what we did, we can find the height. But from here, we also easily figure out the height. Because you can see this is a 15. This is cosine alpha, you get it. Sine alpha, you get it. So this is equal to alpha. So this is B prime CH will be 3, 4, 5 triangle because this sine alpha is going to be 4. This is the 5, 3, 4, 5 triangle. So immediately we figure out the height B prime H equal to 12 because this length is 15, 3/5, 4/5, that will be 12. So that's height of this trapezoid. Even though we don't really need to do this way for this cosine alpha, but that's double use. We just calculate this alpha, cosine alpha, and then find the height of this trapezoid. So the trapezoid, just the top height is 2, the bottom height above top base is 2, the bottom base is 16, the height is 12. We calculate the area. Okay, this is 2, this is 16, this is 12, and then we can calculate the area, 108 from here. Okay, 2 bases, height, and then you get this area. So that's a step 3. Step 4, we're gonna calculate this 2 leftover triangle area. That's a congruent triangle. This triangle and also the other triangle. Both will have the legs R1, R2, and then we only need to calculate one of them, okay? But look at this one, this angle inside this quadrilateral O1, A prime, B prime, C, these 2 angles are opposite angle, they are supplementary. So I already know cosine alpha, sine alpha for the opposite angle. Certainly I know this angle at the same time. So supplementary, we get a 180 minus alpha. And in this blue triangle, we apply the law of cosine. R1 square plus R2 square minus 2R1 R2 cosine 180 minus alpha. And then this one, cosine 180 degrees minus alpha is the same as negative cosine alpha. That's why they change this one to plus. But this value, we already know that's equal to 3/5. We plug in. And so you get this, we can utilize the R1 plus R2. We complete the square a little bit. And then R1 square plus R2 square plus 2R1 R2, okay, minus 2R1 R2 plus, this will be 6/5 R1 R2 equal to 193. So this is the R1 plus R2 square. This is exactly equal to 2 times 5, 10, 10 minus 6 is 4, negative 4/5 R1 R2. So you get this. So we need the R1 R2 in order to calculate the area of the triangle. But O1, O2 exactly equal to, you see this is tangency, this length R1, this length is R2. So they add together equal to 15. So we substitute into this equation. This is 15 square minus 4/5 R1 R2. We can solve for R1 R2 immediately. That's a value will be 40. And then we just calculate this blue triangle area. That will be 1/2 R1 R2 times sine 180 degrees minus alpha. That's the same as sine alpha. So which is 4/5 we calculated earlier. And then you find the area. Once this area of the triangle is found, the other triangle have the same area because they are congruent. Okay, and then we almost done. And see, we just get the same area on the right side. And then we get the hexagon area, just add the two triangles. And also earlier calculated trapezoid area 108. And you find out the answer, 140. And then we are done.